Hi, I'm Yan Zhe from Group F. Today, my groupmate Zheng Yan and I will be presenting our assignment 1, which is Low Energy Building Analysis. In this video, we will talking about the introduction of the building, energy efficient strategies, impact of energy efficient strategies, post-evaluation, and conclusion. The building we chosen is Pearl River Tower, which is located at Guangzhou, China. The Pearl River Tower is one of the world's most energy efficient commercial office towers. The design of Pearl River Tower is intended to minimize the harm to the environment, and it will be extract energy from natural and passive force surrounding the building. And the building is awarded by LEED Platinum, and this building has strategies for seeking zero energy, which are reduction, reclamation, generation, and passive absorption. Next is the facade system of Pearl River Tower. The PV panels act as building skin and power generator. It is located on the roof so it can collect more solar energy and will not be blocked by the surrounding buildings. The double glazed wall system is internally ventilated double glazed wall with blinds on northern and southern facade. It can improve the building occupants' comfort and reduce heating and cooling costs by reducing the flow of heat from the outside to the inside, or vice versa. The exterior facade of the tower incorporates a dynamic high-performance building envelope. The facade system is oriented to optimize the use of daylight while controlling solar loads. The east and west facade is triple glazed wall system. It is the unitized straight glass outfitted with external shades. The external glass is double silver lower height performance glass. It can reduce the radiant heat during hot weather and provide visible light. And it also prevents the heat loss during cold weather. The photovoltaic cells is incorporated into the shade system to capture the solar energy. It is located at east and west to make sure it can capture more solar energy during morning and evening. Motorized blinds or sunshade device within the cavity provide solar shading and glare control. Next topic is about lighting. The building allowing natural light illuminates the space through the triple and double wall facade, thereby reducing the use of artificial light. Besides that, the artificial light that used in the building is fluorescent light. To maximize the use of the fluorescent light, they will use curved radiant ceiling panel as light reflectors to diffuse the light evenly and efficiently. Daylight responsive control is a system that can provide ample natural light to the building interior, and this can help to save more energy while maintaining visual comfort. Other than that, wide filter glass and hanging metal panel are designed as daylight reflectors to redirect the natural light into the lobby and reducing the electrical consumption by lighting features. Next topic is about HVAC system. Guangzhou has a humid subtropical climate, so during summer they need to deal with high temperature and need to maintain the warm temperature of the building during winter. During daytime, the solar energy is collected within the facade and the energy is transferred to the mechanical flow, and it is used as heating for the dehumidification system. During summer, cooling is an essential part to maintain the building is in the thermal comfort. As the temperature is increased, the radiant ceiling system will cool the spaces. Another part of the cooling system is the use of cladding on the board faces of the building. The cavity of the wall traps the hot air from the building exterior and store in a specific area for other use. Furthermore, radiant ceiling cooling system works in tandem with direct outdoor air system and indoor underfloor ventilation to provide improved air change and indoor quality. For the radiant cooling, chill radiant ceiling through perimeter chill bin is used. Cold water pumped through copper pipes in the slab which cool curved metal plates used for the ceiling system and metal fins for the perimeter, consequently cooling the surrounding air. The air supply is come from displacement ventilation. It provides fresh air that is cooled by the chill water system and delivered via a raised access floor. Air supply is located at the bottom to reduce energy consumption. Because the cool air is denser than hot air, so it will sink, and the building takes less energy to cool the building. Next, I will pass to Zheng Yan to present.
So I'm going to talk about the water management in this tower. There are three types of water management in this tower, which the first one is condensate reclamation system. An air conditioning system in a building consists of an air handling unit that circulates air to the occupied space to maintain comfort. The moisture from the space is removed as condensate. Condensate is essentially distilled water. The distilled water is filtered and stored at the derivation tank and ready to use. The next is rainwater harvesting. This is a technology that collects and stores water for human use. This system ranges from simple rain to more elaborate structure with tanks, pump, and filtration system. Other than that is high efficiency chiller system. The chiller heat recovery is used to recover the heat rejection from the chiller in order to produce domestic hot water. In conclusion, the rainwater was harvested from chill surface and the non-potable water is filtered to use for landscaping and toilet flushing. So, the next is waste management. The Pearl River Tower implemented waste management by providing automatic waste collection in the building and reducing waste. What is waste management? The construction industry has been challenged by the unacceptable level of waste generation over the year. Today, the construction industry has been increasingly aware of the importance of both economic and environmental impacts associated with waste generated during both the construction of the new building and the demolition of old structure. So, we're going to talk about waste reducing that this building did. This building has 75% diversion of construction and demolition debris, 10% recycled content building material use, which is environmental friendly organic material, low VOC material, and so on. The last is 10% regionally extracted, harvested, recovered, and manufactured. This purpose is to increase demand of the building material and product that extracted manufactured within the region. Other than that, the building is using automatic waste collection system to collect the entire building waste. The users only need to put the sealed garbage bag into the garbage disposal box between floors and press the button to discharge the garbage bag. And the vacuum in this system will suck and transported by the gravity to the center of garbage disposal container. The advantage of this system is greatly reduce the probability of disease transmission and environmental friendly and efficient waste treatment method. Next, I'm going to talk about the renewable energy. This building relies on added-on technology to generate sustainable energy such as a roof covered in solar panel or photovoltaic windows and wind turbine. This is a building that generates energy. There are 4 wind turbines that built into the belly of tower. The exterior of the building has been shaped to drive air through the turbines to generate up to 15 times more energy than regular freestanding turbines, which can generate up to 1 million kilowatt electricity a year. The wind builds positive pressure on the windward side of the building through the water shading around the side, and over the top of the building creates large pocket negative pressure on the side. But if the air is allowed to pass through the building, the differential pressure is reduced from the front to the back as are forced on the building. So this is showing the upper tunnel and lower tunnel wind speed. The wind testing result indicate that as the air passes through the opening, wind accelerates and the velocity increases. Placing 1 vertical axis wind turbines within each of 4 openings take advantage of the increased power potential of the airstream and provides power year-round. Next, you can see the tunnel-shaped area in the facade to increase the airspeed as it rushes into the building. Last is an innovative aspect of the building design was the use of vertical axis diagram. Next is the photovoltaic. The photovoltaic are integrated with the building envelope, serving dual function of building skin and power generator. The solar radiation was carefully studied and the photovoltaic deploy only the portion of the facade where they yield the maximum result. They are symmetrically located on the building vaulted roof glass and incorporated into the sunshade device on the east and west facade. The photovoltaic can produce about 200,000 kilowatt per year. This is the picture that shows the photovoltaic are placed on the roof, acts as shades and absorb heat to produce electricity. And this is the picture which the photovoltaic acts as the facade to protect the building from solar gain. Now I pass back to Yan Zhe to talk about the impact of energy efficient strategy.
The impact of energy efficient strategies. The double wall maintains a temperature on the inside surface of the exterior wall that is close to the ambient air temperature. The building management system controls the tilt angle of the blinds automatically in response to the solar intensity, solar altitude angle, and solar azimuth angle. The double wall and triple wall facade provide high visual transmittance, and it allows for enhanced daylight harvesting, allowing for a reduction in the amount of artificial light. And integrating photovoltaics with the sunshade can produce about 200,000 kilowatt per year, while protecting the building's facade from solar gain. For the lighting system, the blinds on the tower's exterior automatically open or close depending on the building's lighting needs. This can maximize the amount of the light inside the building when needed while preventing an excess of light from blinding those inside. The ceiling panels are built in a curved shape to allow the light to be dispersed evenly throughout the rooms, and this can reduce the amount of power needed to light a given space fully. For the HVAC system, the radiant cooling panel system is combined with direct outdoor air system and underfloor air delivery that provides improved indoor air quality and air change effectiveness. High efficiency filters are provided to improve the quality of air entering the building. This approach reduces the building's floor-to-floor height from 4.2 to 3.9 meters, and this saving 5 stories of construction. The energy saving associated with the reduced airflow and radiant ceiling system is arguably the most sustainable aspect of the tower design.
The next is water management. The impact of these are water saving and also water recycling, which used for landscaping and toilet flushing. Water is a very important thing to human. Once abundant natural resources is becoming more valuable commodity due to overuse. Water management can help to reduce the water usage are being strained day by day. For the waste management, this can provide environmental friendly and reduce the disease transmission. Waste is a thing that people would rather not to see. It is good to have this automatic waste collection system in the building to maintain the building hygiene than having garbage melt in one of the corner in the building. After that, the renewable energy, which is the wind turbines and photovoltaic, it can produce around 1 million kilowatt a year, and the extra energy can be sold back to the grid. And this can also reducing air pollution, renewable, carbon dioxide free, low operating costs. The wind turbines and photovoltaic are emission-free source of energy that sun and wind can give far more energy than we need to power everything on Earth. Next, the post-evaluation. This chart is showing the annual energy consumption of the tower, which the tower can consume at least 58% less power than an energy code compliant equivalent building by using large scale of sustainable strategies. For the efficiency of the material, they successfully decreased the material usage by 21 meters of the base case building to complete in 309 meters with design case. This is the net zero strategy in Pearl River Tower, which is the baseline, reduction, reclamation, and absorption. Last but not least is the annual power generation capacity. The wind turbines can save up to 850,000 Chinese yuan electricity bill each year, and the photovoltaic can save up to 170,000 Chinese yuan a year. So, the conclusion of this building is the building aim was to build a transformed, integrated, high-performance, environmentally repository design. High performance to mean a structure whose energy saving system would work together in an integrated manner to consume nearly 60% less energy than a traditional building by following the 4 steps, which is the reduction, reclamation, generation, and passive absorption. The tower enhanced thermal comfort, natural lighting, ventilation, acoustic will result in improved human performance and increased human productivity when the corporate office space. Although this building final design not realizing net zero building, but the process has provided strong analytical evidence that a net zero energy super tall tower is clearly within our grasp.